Okay, so again, we're doing the problem left over from Friday's class, example 5 from day 12. We're going to try to find side y using the law of sines so we can get to side x in this problem. So I have y over, remember, make sure just not 58, sine of 58 equals 41 over, how about that angle opposite? It's a little small one, isn't it? Because you guys found the angle next to 62 is what, 108? Yeah? 108? Or 118? 118? So that only left 4 degrees for that angle across from 41. So sine of 41, sine of 4 degrees, sorry. Real quick before we keep going. If you're using law of sines, all 4 values need to be from the same triangle. Right? You can't pick 2 different sides from 2 different triangles. All four values in here using law of sines must come from the same triangle. Now we can cross multiply. 41 times the sine of 58 is equal to y times the sine of 4. And we've been doing this for a while. Divide both sides by sine of 4 to get the y by itself. All right, I go to my calculator. Watch what I'm about to do. All right, take a look. Didn't round. Not my final answer. So I should not round that to 499, 498, 498.4. I write it all out. Now that I know what that side is, now I have 2 options. You guys choose which way you want to go. Now I can use that with, actually only 1 option. Now I can use that with the small right triangle. And I could say, I have my opposite side I'm looking for, which is the height of the falls. And now I have the hypotenuse, which I just found using law of sines. So if I'm looking at SOHCAHTOA, I can use sine. Sine of 62 equals x over, and you can do this if you'd like as well, hypotenuse. Also, let me put up here as well, you could also do law of sines on that small right triangle as well. It's up to you. We could say x over sine of 62 equals, again, my answer that I just found over sine of 90. You can use 90 degrees in the law of sines. It will work for any triangle. So no matter which one you use, same answer. So 440. What are we looking at? Nearest meter. So hopefully your guys are getting 440 meters. If you want a little type of problem that classifies as a word problem that I'm talking about for Thursday's unit test, here you go. I'm not saying it's going to be like this, but this is what I mean when I say word problem. All right, 5 of these. Or maybe you don't get to the answer right away. You got to do a little extra thinking there. All right, but this is what I mean by a word problem that'll be on Thursday's test. Questions, anything on here? Assignment over break. I know many of you were pretty much almost done with it by the time we left on Friday, but anything on here you want to talk about using law of sines? Because today we need to talk about what if law of sines isn't good enough. I have one more technique for you. Nothing? We're good? I figured we'd be all right. Law of sines. Okay. Then we're going to day 13 for me. Go ahead, day 13. Now what happens if I don't have enough information for law of sines, right? What happens if I don't have enough information? So I'm just going to let you guys, like we usually do in here, let's jump right into the fire. Go ahead, set up number 1 for me. set up number 1 for me. Again, you guys that weren't here on Friday, please watch the video, definitely, because right away you're going to see some new notation that we talked about on Friday. Lowercase r is 11. That means the side across from angle R has a length of 11. S has a length of 12, angle T a $1.20, and we are asked to find T, which means the side across from angle T. So that's what I'm looking at now. Can you guys do me a favor? Let me try to do this using law of sines. Don't write yours down. All right, let me try to, because all we have it's not a right triangle, so everything else is, I can't do it. So let me try to use law of sines, and then you guys will see the problem I run into. Ready? I'm going to go T over sine 120. Nobody's got an issue yet. I'm good. Equals, all right, let me pick another side, 11 over about that. I'm stuck, aren't I? I don't want to do sine of r because now I'm introducing a second variable, which is a no-go. I'm stuck. Well, what if I use 12? Same problem. So we all good. Law of sines. Don't have enough info. Can't use it. So I need one more technique for you guys, and that's today's topic. Instead of using the law of sines, let me introduce to you law of cosines. All right, is there a law of tangents? I have no idea. If there is, we're not doing it. But law of cosines. And it is a little bit more involved than your proportion law of sines. I am not going to give it to you either on Thursday, so this is for you to remember. So here it is. It's up here anytime you need to reference it. Law of cosines. Let me write it down, and I'll explain each piece to you. A squared equals b squared plus c squared. Oh, over there. Little Pythag, right? This is how the law of cosines was born, using Pythagorean theorem. Minus 2 bc, and then finally times the cosine of capital A. Woo! All right. What does each piece mean? Well, triangle, 3 sides. That's A, B, and C. Okay, A, B, and C represent the 3 sides of a triangle, but what side do you put where? Here you go. In for A. That does not mean side A. That is not side A. Because is every triangle we do ABC? No. Hi, RST. Right, so it does not mean side A. What it means is I'm going to plug in the side across from the given angle in the problem. So a side across from given angle. That's what's going to go there. Because when you use law of cosines, you're only going to have one angle. If you have 2, you better be using law of sines instead. Right? Everyone, law of sines, I need 2 angles. Law of cosines, you only need 1. So there should be only 1 angle being talked about in the problem. If there's 2, we're using law of sines instead. All right, so there's one side. The other 2 sides of the triangle, that's B and C. Take a look. B and C here are the same B and C here. Those are all the same values. And those are the other 2 sides. Those are the other 2 sides. And then finally, remember I said there's always 1 and 1 angle only involved? That's right there. That's your angle right there. That's your given angle. Okay? So I put the cosine of whatever angle measure that is there. All right, we're ready to use it here. We already found out law of sines. I don't have enough information, so now I introduce you to law of cosines. All right, what side now, 11, 12, or T, is going to get plugged in for A here? Well, let's answer this. What's the angle in the problem? What's the angle in this problem? 120. What side is across from it? T. That's what goes there. The side across from the angle in the problem. So T squared equals B and C, other 2 sides, does not matter the order. So 11 squared plus 12 squared minus, remember B and C are the same B and C's we just squared. So 2 times 11 times 12. Any issues so far? Times, remember this is all multiplication here. After the subtraction, all multiplication. Cosine of my angle, 120 degrees. And there it is. Now you'll notice, you'll notice there are no variables on the right side. It is all calculations. And what I'm going to recommend it to you, just put it all in one line in your calculator now. Don't try to do 11 squared, write it down. 12 squared, write it down. No. That's where mistakes happen. There's no variable here, so calculate it all at once in your calculator. That's what I would prefer. Your calculator should be giving you a nice whole number. That number does not represent t, though. Okay, that's not side t's length. That represents t squared is 394. That's t squared, not t. So to finish it off, you guys know, take your square root. And then nearest integer we talked about. What is an integer? We've talked about that already. That's a whole number, positive or negative, but it can't be negative here. So we got 20. Okay. Yes?
To find like a second angle, you have to have a right triangle, right?
What do you mean to find a second?
Like, you know how we had a thing like you take the two sides and like the sine of x.
Yes, you need it correct. You need a right triangle to do that. Yes. Yep. Because there is no such thing as opposite, adjacent, hypotenuse if it's not a right triangle. Correct. Anything else here? I know one doesn't make you great. All right, we're going to use this now in different ways. We ready? All right, set up the second one now. The information I gave you is a little different than number one, and we'll show you how to use it. But let's set up triangle ABC first. Side A, a length of 4. Side C, a length of 6. Ooh, how about this, huh? I don't give you the angle measure, but I'm telling you the cosine ratio is 1/16. So watch what's a little different here when we use law of cosines. Watch what's a little different. And let me just put this out here. How do I know I'm going to use law of cosines versus law of sines? Literally, the word cosine is there for you. It says use law of cosines. Okay. And what do we find in side B? Okay. I know a degree measure is not there like it was in problem 1, but what angle do you know anything about? What's the only angle we know? There's 3 of them up there, but we only know info about what angle, and what angle is that? Angle B. I know nothing about A and C. It's just angle B. So what's across from it? What side's across from it? Side B. So guess what? That's how I'm starting this law of cosines off with, B. Guys, I know nothing about angle A and C. The only thing it's telling me info about is B. So I use the side across. That's how I started off. Equals, here we go, other two sides squared, right? 6 squared and 4 squared. Great game back in the day, too. Anybody? 4 squared? Anybody ever play that at recess?
Like
yeah.
Like the 4 spots.
Yeah, I don't know. You guys had names for it. We just moved around. Whoever was in spot 1 got to serve and back and forth. Right? Anybody ever put a little spin on it? Or then you had the rules? No? Anybody? Yeah? Anybody ever play with, or maybe you were that kid that just made up rules as they went along? Like they get the ball and they'd be like, cherry bomb! And you'd be like, what's going on here? They just make up rules as they go? No? Or maybe you were that kid. Good times back in the day. Minus 2 times 6 times 4. Ooh, now watch. Watch it here. Watch what's about to be plugged in. Last time, we did the cosine, where is it? Cosine of 120, because that was the angle measure. But now, is my angle measure 1/16? Is that what angle B is? 1/16 of a degree? No. So I'm not going to put cosine of 1/16. I'm just going to put 1/16. That is the value of cosine of B. Notice the difference between this one and number one. The only time I'm going to put cosine with it is if it's an angle measure in degrees. All right. If I actually know what the angle is in degrees, I'll put cosine with it. If not, like I did here, I know the value, just plug in the value, 1/16. And then yes, just like we did on problem 1, there is no variable on the right side, so I can just calculate that all on my calculator. Then you'd always have the kid that would put a lot of spin on it, and you'd be going one way, and the ball would be going the other. You look foolish. You guys get a nice perfect number, literally. Seven, all good? No issues with 7? So see the difference? Because I'm going totally in a different route now. Everyone all right on 1 versus 2? When to put in my fraction versus cosine of the angle. I need to know what the angle is to put the cosine with it. All right, now, all I've been having you guys solve for is the left side. What happens now if there's a number plugged in here and I got to solve for something on the right side? All right, so that's where we're going to with these last 2 problems. All right, let's set her up. See how you know I'm not finding a side now. I know all 3 sides. I'm trying to find what is the cosine ratio from angle B. And I can't do adjacent over hypotenuse because it's not a right triangle. All right, so it's going to be law of cosines because, again, I'm looking for cosine of B. Which side do you think I'm going to start out with then? 10.75? Why 7? I'm looking for the cosine of angle B, so that means I'm going to start off with the side across from angle B, which is 7 squared. Okay, watch what happens here at the end. 10 squared plus 5 squared minus 2 times 10 times 5. All right, ready? Cosine B, and that's what I'm solving for. I need to know that value. So I'm going to need your help here, algebra studs, in getting this value all by itself at the end. So at the end, I want cosine B equals whatever we have. All right, now notice now, my variable's on the right side. So I can't just go and calculate everything here. It's not going to work, okay, because the variable's over here. But we can at least calculate some values here. So help me here. 7 squared, 49. 10 squared, 100. 5 squared, 25. Minus, I can calculate 2 times 10 times 5. I believe that's 100. Times cosine B. All we did, calculations. Ooh, now I have an important question. How many like terms do I have here on the right side? What can I combine? Can I combine all, all 3 of those? What do you think? So can I do 100 plus 25 minus 100 in my calculator? You think I can do that? Ooh, some of you are on the fence right now. Well, let me ask you this. Ready? Can you combine these 3? Can you combine all 3? Oh, now I got some people saying no, no, no. Correct. Same thing, guys. That's your variable we're solving for. So no, you cannot combine all three, but you can combine the first two. The 100 and the 25 we can combine. So I get 49 equals 125 minus 100 cosine B. I know it's tempting, but can't combine those two. All right, where are my algebra studs now? I need cosine B by itself. What's your next move? Get it by itself. I got to start moving stuff over. I've combined all my like terms I can. Now I want to start moving things over. What gets moved and how? Subtract 125 over. Boom. See you later. What do I got there? I've been doing this 3 times already. Negative 76. Ooh, alert, alert, alert. Common mistake at this point. A lot of students, common mistake. They drop the negative. It's not 100 cosine B. The negative still, we didn't do anything to it. Negative 100 cosine B. All right, algebra studs, finish it off. How do I get cosine B by itself now? That's what I was thinking. Yeah, divide by negative 100. Good. Get that out of there. And as you go to the calculator, this one's not too bad because the decimal is very short. But if it's long, I prefer the fraction, please. All right. If your calculator gives you the fraction, I'd probably prefer the fraction instead of the decimal. But the decimal is not big of a deal because it's only 0.76. But, 19 over 25 is going to be my answer. And that's it. Do we move on? No. There's your cosine ratio for angle B using the law of cosines. There's your cosine ratio. All good. Okay, one more thing I'm going to ask you to do with the law of cosines, and that is not find a side, but find an angle for me. All right, find an angle for me. So we got triangle RED. Oh, that spells red. Way to go. Good job. Good job. 5, 5, 8. What's angle E going to be? Oh, before we even start, I don't know how this is going to look on my paper or what I'm going to type into my calculator, but I at least know how this is going to end. I am having you find an angle. An angle. And I don't care if we were doing SOHCAHTOA. I don't care if we're doing law of sines or right now law of cosines. If I have you find an angle, how's this going to end at? How's this going to end? Doing what at the end? Come on, it hasn't been that long break. Shift, right? Anytime you find an angle, we're going to have to do the shift. Arc, right? Arc sine, arc cosine, whatever the case is. So at least I know how this is going to end. At the very end, before you have your angle written down, we're going to have to do the shift button. All right, let's set this up. What do you think? 5 squared or 8 squared to start it off? 5 squared or 8 squared? 8 squared. Why? It's across from the angle we're looking for. So 8 squared equals 5 squared plus 5 squared. The other two sides minus 2 times 5 times 5. Cosine. Again, if you guys always want to use X, I don't care. I don't. I'm just going to use the angle we're looking for, though, E. So this is going to be the same problem as number 3, but at the end, instead of leaving cosine E equals this fraction, we're going to go second. Or it's not second. You guys have shift for my fraction. So here we go. 64, 25, 25, minus 50. I showed you we cannot combine all 3. We can only combine the first 2 terms. 50 minus 50 cosine E. I know it's tempting to write a 0, but even if you did, what the heck are you going to do there? So don't combine them. But let's move the 50 over. Uh, 14. Don't forget the negative, common mistake. Any issues so far? We're good. All right, divide both sides by negative 50. So here's how we ended the last problem off with, right? By finding the cosine ratio. Why am I drawing a blank? Negative 7 over 25. Okay, that's the ratio. I want the angle. So ratio to angle is where the shift key comes in now, or your arc cosine. So the ratio to angle, shift button. And we're rounding to the nearest degree here. 106. And because we're in honors, I want to talk about why that answer makes a lot of sense. And I'm pretty confident that we did this correctly. Why does 106 make sense? In my diagram, is there any shot R or angle D is going to be bigger than 106? It's impossible. Can't go over 180. And conveniently, where's the 106 located? Across from 8, which is the largest side, right? Largest side across from largest angle. So I'm pretty confident it's going to be 106. Last thing, because I'm going to let you do number 5 on your own. I will never ask you to solve for B or C in the law of cosines. If you find yourself solving for B or C, something went wrong. The only thing I'm going to ask you to solve for, that side, the cosine ratio, or the angle. Those are the only 3 things I'm going to ask you to use law of cosine for. I will never ask you to solve for the other 2 sides. All right? All right, we're done holding hands, kids. You guys have number 5. The answer to number 5 should be 96.9 degrees. So if you can come up with that, move on to the textbook homework. And if you can't, you're struggling to get that, it's probably a calculation thing, call me over. But you should end up with 96.9 degrees when you do number 5. All right, so try that one out on your own. And once you get 96.9, get your Chromebooks out,